So in the previous video we have seen the analysis of eccentric load, that an eccentric load can be written as a combination of direct load and a moment. The direct load produces direct stress and the moment produces the bending stress. Now we will try to find out what are the total stresses when eccentric load is acting. So this is the last part of our analysis, that is the force is acting and a movement is acting. Now what we'll do, we'll try to analyze these two separately. That is, in the first case we will apply only the point load, that is the direct load on the member. So we are applying a direct load here, and in the second case we'll be analyzing only the movement. So this method of separating a complex problem into two separate easy problems is called as, or is defined as, the principle of superposition. Okay, so we'll be seeing it in the third unit, that is in fixed beam. This principle we have to study in detail, but for now somewhere this is used, that's why I have recalled. Okay, so the total problem here, which is having a direct load and movement, is separately written as direct load plus a movement. So if we add these two cases, we'll get the final stresses. Now what are the stresses that will be developed in the case of direct load? So in case of direct load, if this is a zero line, then the stress distribution is constant. The stress distribution here is constant and it is of compressive nature. It is of compressive nature. These values, these values are sigma 0 and sigma 0. Whereas in case of a member subjected to movement, a member subjected to movement, if this is a zero line, if this is a zero line, then there will be compression on right hand side and tension on left hand side because of the clockwise movement. So this is a compression here and this is the tension. This value is sigma b and this is also sigma b. Now as per our analysis, that the total problem can be divided into summation of individual problems. Now similarly, whatever the total stress will be there, that total stress will be the summation of these two stresses. So we'll draw these two stresses here. The first stress is the direct stress. So this is direct stress, and the next one here is bending stress. So this is sigma 0, this is sigma b, this is sigma 0 and this is also sigma b. Now what will be the total stresses here? The total stress will be summation of these two stresses, that is on right hand side it will be sigma 0 plus sigma b. You can see the direction is in downward direction, that is compressive in both, but in the left hand side this portion is negative, so the value will come somewhat less and this value is sigma 0 minus sigma b, as this is negative bending stress. Now if we connect these two, then this representation is the representation of total stress when an eccentric load is acting. Okay, so on left hand side it is sigma 0 minus sigma b, right hand side it is sigma 0 plus sigma b. Now this is nothing but sigma max and this is nothing but sigma minimum. That means maximum stress, that is sigma max, it is sigma 0 plus sigma b. And what is sigma 0? Direct stress, sigma b bending stress. Similarly, minimum stress is denoted by sigma minimum, and this is equal to sigma 0 minus sigma b. Very important. On this only most of the questions are asked from this unit. So what are the maximum and minimum stresses? Maximum stress is direct stress plus bending stress. Minimum stress is direct stress minus bending stress. This is the representation. This representation is for direct stress. This is for bending stress. And this is for resultant stress.